Hello everyone, my name is Zhi Guo. I'd like to introduce our work in document-level neural machine translation using BERT as a context encoder. Most neural machine translation systems encode individual sentences without using the surrounding context. Recently, a lot of researchers try to build more powerful document-level neural machine translations, which can integrate more consistent and coherent translation results through the long ranging of context information. Since late 2018, BERT and its variants such as Robota or BERT, Electro, have achieved great success in many natural language understanding tests, including multi-task learning, such as GLUE, question answering, such as Squad. This leads to a natural question. What about text generation? Can we use BERT to improve text generation models such as neural machine translation? There are two pre-training tasks for BERT. Task 1 is a masked language model. Task 2 is a next sentence prediction. BERT is able to capture the relationship between two sentences. Since the next sentence prediction task is to predict whether two sentences are adjacent. A natural assumption is that the relationship information is helpful to model the context information for document-level machine translation. In this work, we propose to use BERT as a context encoder to achieve contextual representation, and we extend the transformer model to take advantage of BERT contextual representation. As the input for BERT context encoder, we concatenate the previous sentences, the current sentence, and the next sentences together. The CLS and the SEP are special tokens for BERT. However, in this work, to balance the accuracy and the computation cost, we only use one previous sentence as the context. This is the architecture of our proposed model. Our model is based on transformer architecture. CB is the last layer output of a BERT encoder. It is then integrated into both the encoder and the decoder by using multi-head attention. The multi-head attention can deal with the cases that BERT module and neural machine translation module might use different word segmentation rules. However, if we directly combine the output of the two attention mechanisms, the influence of document-level context information will be enhanced in an uncontrolled way, as the context information will be added to every layer. Also, different source sentences require different amount of context information for translation. Therefore, we propose to use context gate. Those two context gate to combine the output of the two attention mechanisms. We use two document-level machine translation datasets, TED and user commentary dataset. This is the statistics of those two datasets. For the baselines, we use HAN hierarchical attention model, SAN selective attention model, QCN capsule network-based model, document transformer, flat transformer, BERT fused model. This is the experimental results. Uh, for the previous work's results, it is from this paper, except BERT-fused model. BERT-fused model is our implementation using document input. As we can see, by leverage BERT document context representation, our proposed model achieves significant improvements over the sentence level transformer. Especially, our model achieves new state-of-the-art results on news commentary dataset, showing the effectiveness of our proposed method. In the ablation study, we investigate the effect of context integration. As we can see, integrate context information into the encoder can achieve larger improvements than the decoder. By integrate context information into both the encoder and the decoder, we can achieve the best results. Previous work shows the context encoder in multi-encoder document level neural machine translation system cannot really capture context information. Following the previous work, we used the true context and the wrong context as the input for context encoder. As we can see, the true context input can achieve the best result. This implies our proposed model can really capture the context information. We have presented a method for leveraging BERT to capture context information for document-level neural machine translation. Experiments on two document-level machine translation tasks demonstrate the effectiveness of our approach. We have shown that our approach can really capture the context information to improve the translation performance. For future work, we plan to compress our model into a lighter version to leverage more context sentences. We plan to do more experiments on large-scale datasets and some other language pairs like Chinese to English.